Hello! So in this video, we're going to try out both method 1 and method 2 for the surface integral. Alright, so from your lecture note in example 1, you're supposed to find surface area of sphere with radius A. So you know that you are looking for surface area of a sphere and it has a radius of A. So in this case, we are first going to try out with method 1. Alright? So do you remember method 1? Method 1 is where your z is expressed in terms of your function of x and y. And your surface integral will then be just the double integral of my square root of 1 plus df over dx square plus df over dy square. And it's supposed to be dA, right? So in this case, it will just be dx dy. Alright? So let's explore this method. So how do we go about it? So you see that you are going to find the z of your function being expressed in terms of your x and y, and in this case you are only given that, okay, find surface area of sphere with radius A. So that also means that first we need to come up with the equation, isn't it? And if you remember correctly, try to recall what the equation of your sphere will be like. If you remember your basic maths from somewhere that you learned last time, if you just have a normal circle, you will have x squared plus y squared equals to r squared, right? Similarly, if we are talking about sphere, the equation for sphere will then be an x squared plus y squared plus z squared equals to r squared, right? And I'm just replacing it directly with A because in this example, I'm talking about radius of A. Alright? So the general formula would be x squared plus y squared plus z squared equals to r squared. So first, now I have already got this. So remember, now I want to find my z, which is my function of x and y. So what do? It means that I'm going to translate this general equation here and rearrange it to z. Alright, so in this case, z squared will then be a squared minus x squared minus y squared, right? And if I'm getting the z itself, that basically means that it will be a square root of my a squared minus x squared minus y squared. Alright, if you get a little confused with this equation here, please try it step by step. First, find what is your z square, and after finding your z square, you find your z, and you should be able to get this equation here. And because I am going to do partial derivative of it later, I am going to, for me, I like to express it in terms of this in bracket. I can also express the square root with the power of half, right? So that is one. So next, what do we find? So recall that in this formula here, we actually need to find my df over dx and df over dy. Alright, so let's start with the first term here, which is df over dz, df over dx. Alright, so once I have got this, and this is actually my f of x and y, so you just double check, alright, it is actually expressed in terms of x and y. Know that a is not the variable. A actually is considered a constant, alright, constant of my radius. So in other questions, if they actually give you in terms of number, so a is representing any number. It can be 8, can be 9, and so on, alright. So I have expressed this correctly. Now the differentiating part. So I'm going to do partial derivative. I'm going to differentiate it with respect to dx, this expression here. So what would I get? So it will be half. This power here will be brought forward. And I'm just copying back the whole thing here, which gives me a squared minus x squared minus y squared. And this one, I have to minus 1. It gives me negative 1 over 2. Am I done here? I'm not. Because why? Whenever I have an expression, I have to differentiate whatever that's inside the bracket again with respect to dx. So in this case, I will have, if I differentiate this expression with respect to dx, I will get negative 2x, correct? So I can simplify this, and I will get something like this, negative x over square root of a square minus x square minus y square. Alright, see that this one is negative half, so I can actually express it in terms of x over this whole expression, power of half. Yeah, so now that we are done with these, let me just put this up a little bit. Next, I'm going to find df over dy. df over dy, once you have got this, is kind of similar, isn't it? Only that now you're differentiating it with respect to dy. So I'm going to get the same thing again, but only that now I'm differentiating it with respect to dy. So the first two terms will still be the same, and then I multiply with, if I differentiate this term, I'll get negative 2y. Again, simplify this, it leads me to negative y over square root of a square minus x square minus y square. Alright, now I have found my df dx, I have found my df dy. Let's put all these terms, this term here and this term here and this term here, into the equation. Alright, I'm going to scroll this up, and I hope that you are actually at least just watching it to understand it and then try it out later, or you might just be checking out your answer to, you know, validate that it is actually correct. Alright, so again, ds earlier would actually be just the square root of 1 plus df over dy square, right? So remember, when I take my df over dx and I square this up, alright, this will then give me this one here. Alright, this gives me x square over a square minus x square minus y square, correct? And then of course, similarly, for this one, the second term, I will get a plus of y square over a square minus x square minus y square. And when I have something like this, I usually like to make a common denominator out of it, which this then will be a square minus x square minus y square over a square minus x square minus y square. You see, right? This will then just be simplified back to 1. Alright, so see that now this has common denominator, so I'm gonna just add everything up in one line. So I have x squared coming from the second term, then I have y squared. Excuse me. So from here itself, you can see that after simplification, this is minus x squared plus x squared comes 0. And this is negative y squared plus y squared. It will then leave me to this simplified version here. And now that this is my ds, which means when I want to get my s, I basically just put a double integral in front and I get a dA for it, right? Now I can forget about this already. So let's look at this. Alright, for dA, remember, if we're talking about Cartesian coordinate, then it just depends on dx and dy in this, or dz. But remember the shape that we are given? We are given a surface area sphere of radius a, isn't it? What does this mean? This basically means that it needs polar transformation. There you go. So again, what would be my x? If you recall, it will be my r cos phi, and my y is r sin phi. And then my dA will then be r dr d phi. Alright, so that's one thing about method 1, because it actually is easier for it to be in Cartesian plane. So if you want to solve it with method 1, you can still do this. So now, since we have sphere and we have then already converted this into its polar equivalent. So I'm going to replace this x with this and replace the y with this. Okay, so let's rewrite this. It will then give me my s equivalent to my double integral of a over, right, a square. Sorry, earlier, remember this part here? This is a over, I forgot the square root. And thank God I just realized. So see that over here, I actually have the square root, right? So in this case, this is a square. So if I take it out, it will be a. I have a square root over here. There you go. Now this is correct. So continuing from wherever that we pick up from. So this will then be a square root of a square minus my x will then be replaced with r square cos square phi minus my y square r square sine square phi. And this dA will be replaced with r dr d phi. Alright, such a long one, but never mind. So let's see over here. So in this case, right, how do you look at this? So r, I'm just gonna write it here, ar over, again I have the square root here, so this will be then a square minus r square. And now if you remember, this is a common factor, I take it out, I will get cos square phi minus sine square phi plus, right? So that it applies to this formula here. So then I'm just gonna push this up, and don't forget my dr d phi from earlier, yeah, from this side here, because the r I already put it here in this part. Remember that this, according to my trig identity, also gives me 1, correct? Now this then leaves me to a much simplified version, ar over square root of a square minus r square dr d phi. So see to that earlier we're talking about sphere of radius a, right? So sphere of radius a will then give me an r. What will be my r again? My r will be from limit 0 to a. And then this one is actually my phi. My phi will be equivalent from 0 to 2 pi. Alright, because we're taking the whole sphere. So in this case, how do I do this? That's such an interesting one, isn't it? So picking up from your maths basics, from here I see that we can solve this with integration by substitution. If you have another easier way to do it, please carry on. For maths, there's no one way or one method to do it. So in this case, I'm going to get the more complicated version, which is u. Alright, so let u be equal to a square minus r square. So what do we do next? Usually what I'll do is that, okay, du over dr will then be negative 2r, right? So if I rearrange this and put this to the right side, then I will get r dr equivalent to negative du over 2, correct? So my dr gets transferred here, and then my negative 2 gets transferred this side. Alright, so rearrangement of it gives me this. So when I have this, alright, remember earlier I have my r from 0 to a. So now let's work on the limit of the integral. So the first one, r is 0. Alright, I'm talking about this one here. So when r is 0, I'm going to replace it with my u equals, so this becomes u equals to what? A square minus r square, right? So u then becomes just a square. Alright, and when r is equals to a, I'm gonna replace this with u equals to a square minus r square. So when I replace r with a, then a square minus a square will give me 0, right? So this gives me the new limit for this part here. Alright, so now what's next? After doing this whole thing, which is my integration by substitution, now substitute it back to this original version. So let's do it step by step, yeah? I would like to just start off with this expression. So if I rewrite this, I have a. My r is what again? My r is actually my r dr, sorry. So I see that this is r dr, isn't it? So r dr is earlier negative du over 2. Alright, so I still have a d phi here. And then over, remember earlier, a square minus r square is actually denoted by u. So I will just have this as square root of u. And now this first one here, we have searched for the limit of integral in terms of u, isn't it? So r limit from 0 to a, 0 as the lower limit, a upper limit, I'm going to replace it with this. So notice that this now becomes a u equals to a square to 0. So it doesn't matter, it doesn't mean that every time 0 must be at the bottom. So just be very careful with this, yeah? And this is actually based on whatever calculations that we did earlier. And of course, don't forget the other integral, which is corresponding to my phi. Phi will then just be 0 to 2 pi. Right? So now that I have this, let me scroll this up. So notice that I can take out my negative 1 over 2, and a is actually something here, right? So if I am rearranging this again, I can write this as negative a over 2, alright, corresponding to this one here. And I can write this as u to the power of negative half. So remember, u power of negative half is actually equivalent to 1 over square root of u. So it's actually just the same. And the reason why I'm just separating this as it is because, well, for integration, I'm only concerned with the variable that is involved with it, right? So in this case, this will be a du from here. And then this will be a d phi. I just took this out because it's just going to be a constant. So but again, if you put this inside, it's also okay, up to you. So this is from a squared to 0. Phi is from 0 to 2 pi. Now that I have here, I will solve this one first. So when I have this, I'm just going to rewrite the first term here from 0 to 2, pi negative a over 2. So this, when I integrate it, u to the power of half plus 1 will give me 1 over 2 over 1 over 2. Lower limit, a square. Upper limit, 0. I'll just rewrite this. this will then give me 1. If I look at this, right, let me just rewrite this whole thing. 2 pi 0 negative a over 2. If I replace this with upper limit, it will just give me a 0. When I replace it with the lower limit, this gives me a power of half. A square, sorry. So that will be a square. And then a square power of half. So you see what I'm getting at, right? My u is actually my a square. So power of half over half. Alright? And this will not, because this is over half, I can also, it is also equivalent to 2a square. Let me just put it here. D phi. So you can solve this, and when you solve this, then you will see that this is actually a, isn't it? When you solve this actually gives you a. Alright, I'm not going to go much into detail in this. And your 2 will actually be cancelled out because this 1 over 2 here will then be 2. 2 can be simplified. Alright, so in other words, you have a over here. You have 2a over here in a way. Alright, so when you take this and you multiply with this, alright, sorry, there's a minus here, then it gives you, so please do try it out yourself. Yeah, I know that this can actually look kind of messy. I'll get a square d phi, and when I scroll this up again, when I have a square, again, nothing to do with my phi, isn't it? So a square is just a constant. So when I integrate 1 with respect to d phi, we'll just get a phi from 2 pi to 0. Alright, so over here I'll get 2 pi a square, and therefore the total surface area, because if you look at the limit that we actually searched earlier and all that, the total surface area will then be 2 multiplied by this answer here, 2 pi a square, which is 4 pi a square. Alright, because if you remember, what we have found earlier is of this here. Alright, we have the surface of this part here based on the limit that we set, therefore we just multiply by 2 to get the whole sphere here. Alright, again, we have more than one method to do this, so if you have an easier method, just please go ahead. So this is method 1. So imagine how long the steps are, right, from wherever that we started from earlier, based on this surface area of sphere with radius a. Alright, just like I mentioned, this method 1 is sometimes easier to do with things on Cartesian plane. So let's explore the same question, but we are going to solve it with parameterization. Alright, then you compare and see which one actually is easier for you.